G'day everyone. Well, this is a bit of an opportunity to show you how to use electrolysis to remove rust from steel objects. I've got this brake rotor here which I'm going to be making into a flywheel, a high-speed flywheel. As you can see, it's a little bit rusty. I did find it on the side of the road a while ago, and it's been sitting outside ever since. I've got the worst rust off of it, which just with a wire wheel on a cordless drill, and that did the job alright. But the actual way to get most of that rust that's actually eaten into the steel is to use electrolysis. Things you're going to need are a tank or a tub full of water. In this case it's fairly big because it's quite a large object I'm cleaning. You're going to need bicarb soda, quite a lot of it in my case as well. A sacrificial anode. I'm just going to use this old CRT aperture grill since it's clean steel. A lot of it's a lot of scrap metal. It's all painted and doesn't really work as well. But I'll just cut that up and flatten it out and just stick it in the tank and just have that suspended above it. And you're also going to need a supply of high amperage. I've got these computer power supplies here. I'm probably not going to be using all of them, but I've got them all readily available here in case I blow one up or get water on it. Sorry. A little warning: never use stainless steel for the sacrificial anode because you will end up with a solution of hexavalent chromium, and the EPA classes that as a hazmat. It causes some rather nasty defects and things, and you've basically got to call the EPA up and get them to take it away because you can't just pour it down the drain. It is illegal. It's a rather nasty contaminant. But anyway, I'll get things set up and show you how it all works. Okay, so first thing you got to do is put in your bicarb soda. This basically causes the water to become slightly salty and slightly conductive, and causing the basically electricity to flow through it into your workpiece that you've got in the tank. I don't want to use all of this up because my mum needs some for her cooking, but I will put at least enough in to make it stronger, and I can add more if I need to. Yeah, the reason I got that there is that's got a motor stator on the other side. That's just pulling the tub in, stop it bowing out, because water, as it's trying to push outwards, it'll push the tub out. But just put a bit of that in there, and make sure you mix it in thoroughly. See how it's all on the bottom there? I'll mix all that in and make sure it's all causes the water to go into a salty, strong solution. So first thing you'll do is add your bicarb soda in, as I've done. You can see bits down the bottom there. Make sure you mix them in thoroughly, because that'll just clump up down the bottom and be a bit of a waste, because this stuff is sort of expensive. But once your water will go a bit cloudy, and then it'll go clear again. Once it goes clear, you know that you can add a little bit more in. But never do this in your sink, because your metal sink tub is made of stainless steel, and it will basically turn into a sacrificial anode, and you don't want that because you'll end up with hexavalent chromium. But plastic tubs are alright, even steel tubs or aluminium will do, as long as it's not in circuit, as in you don't have that connected to your negative, or your positive should I say, and that's if this was made of aluminium. You make sure it's not connected in part of the circuit, it's just holding the solution. Once that's done, you can now get your anodes in. As you can see, I've taken the back part off. No, actually, there's a special name for that on the I know somebody who's worked with CRTs will know what that is, but they can just sit down there like that. And then the front part of it can just go in like that. If it'll fit. It doesn't have to be a perfect fit. It can just go in rough like I've done. But as long as it's there's area for the electrons to flow from that to the brake rotor, it should work alright. Well, it took a little bit of fiddling and playing around, but I did manage to get it in there. I had to move the anodes to the side of it, but that's alright. It is, as you can see, it is angled slightly, so the base of it will get electrons hitting it. But I did happen to see an earwig in there, which is something rather entertaining. I don't think he's going to be very happy when I pump about 10 amps through this thing. Yeah, there he is there. He's doing a whole circuit of the brake rotor. He's probably thinking, how the hell did I get in here? Oh well, earwigs are a bit of a pest species in Australia, so he can suffer. Yeah, I was a little bit overkill with the power supplies, but they are working. I've got all three of them running at the moment. But they're all putting out about 10 amps at 12 volts, so it's pretty much what I was after from this. But when you wire it, your positive goes to your anodes, and your negative goes to your workpiece, which is down inside there. That's just one of the support wires that's holding it up. It's just a bit of a galvanised tie wire I use to fix the whole lot together. When you've got more than one anode in the tank, make sure you've got a bridge wire connecting the two. And also make sure it's not contacting your workpiece, because you'll get a short. But that foam that's building up in there, that is hydrogen gas. Don't let it build up too much, because if one of your power supplies arcs over or something, it will ignite, and you don't want it doing that. As if these ends were enclosed and it was to fill up with hydrogen, and one of these was to blow up, it'd probably send this whole lot flying straight up through the roof of the shed. Even the DLP chassis and everything would go up. It's not something you want to have happening. In fact, what I am looking into trying to get is some clear flex pipe, Plastiflex I believe it's called, just to run up over there and down outside with an exhaust blower at the end, just to vent out some of these gases and things. But it's working alright at the moment. Well, I'd say the brake rotor's been in the tank for about 4 hours or so. The sacrificial anodes have done their job. There's a nice layer of rust on surfaces of it, but it can probably be used again actually. Like, that top part's completely untouched, so I'll dry it out and put it in storage. Same with that one, that's got hardly anything on it. But I'll keep those for next big object I get. But anyway, here's the end result. And yes, it is the same rotor as in the start. In fact, you can even see score marks from the brake pads when this was still on its car. But when you pull out your object, it will be covered in black sludge. It's still a little bit up in here. It's that colour. Just rub it off with a wire brush. Works the best if you're really fussy, but I just use a towel, since this thing's only going to be used as a flywheel. It's not going back on a car or anything, but, well, not that it can, because it's flogged out and turfed. But yeah, it's come up real nice. In fact, you can even see the lathe marks when they first made this thing. But next step will be to take it into school and machine an aluminium bush that'll just stuff into there, and then turn a hole right the way through it, and put a big photocopier guide roller that'll just go right through the centre of it. And I can turn the ends down on that and stuff some car idler bearings on to yeah, I'll make up some sand so that they can sit on, and this thing will just be belt driven off an electric motor or something. Might even be able to machine a pulley groove on that or something, or turn it down slightly so I can make a flat belt pulley stay on it. There's tons of things you can do with stuff like that. But feel free to leave any comments and questions if you got any. I'm more than happy to answer stuff. Be safe when you do this, especially at 240 volts, and water does not really go well together, but as long as you keep it isolated, it should be all good to go. And yes, same old thing, don't use stainless steel because of the nasty stuff it creates. But yeah, thanks for watching.